Hey guys, how's it going today? Hey, back for a follow-up on the test that we did about pouring chlorine into water. Will it raise your pH, and if so, by how much? Okay, now a recap on this. First day, what I did is I poured in 8.4 ppm of chlorine into one bucket, nothing in the other. Both these the water here tested the same at 7.79, and we had an alkalinity of 170 in the water. Okay, now after I put in the chlorine in this bucket here, pH came up to 7.88. 1 point. It came up an entire point after pouring in 8.4 ppm of chlorine. Now again, this is going to be the same as pouring in a gallon in a 15,000 gallon pool. It's going to be the same no matter what. It's all the same. 8 ppm is going to be exactly the same rise in pH. Okay, I'm doing this test to show that Robert Lowry is right in what he says, because I know there's a lot of people out there still that believe they oh, the chlorine raises your pH and you've got to add acid in it to offset that pH. And what we're doing here is proving that no, you don't, because it is only, just like Robert Lowry says, it is only temporary. The pH will go back down. And that's what I'm going to prove right here with these tests. Okay, now, second day, what I did is I tested things again, and chlorine bucket came down to 5.2 chlorine with a pH of 8.16. Okay, so water bucket, the bucket with no chlorine in it, pH 8.12. Okay, now, what that just proved, since these two buckets were basically the same, really close to being the same on the second day, is the pH rise from the chlorine is only temporary. So there is no need to add that extra acid to offset that chlorine rise, because it will come back down. And you're asking, maybe asking, okay, well, why did the pH jump up from 7.79 and a 7.88 to an 8.1? So, okay, and the reason for that is because CO2 off-gassing. Doesn't really matter in a pool, in these buckets, anywhere, you're going to have off-gassing of CO2. Off-gassing of CO2 will raise your pH. Aerating water will raise pH. It's because you're off-gassing CO2. And that's why the pH goes up. Now, also I want to point out is equilibrium of pH is 8.2 to 8.3. So no matter what, pH is always going to want to come up. Now, and again, here's another thing that Robert Lowry it says. Both of these buckets, we had 170 alkalinity. Now, that pH came up from a 7.7 and a 7.8 to 8.1. That's quite a bit of a jump. Now, why did that happen? Well, so fast, I should say, is because that alkalinity being at 170. That's why. That pH just came up a lot faster. Now, if these buckets had an 80 or 90 alkalinity, there's no way that pH would have came up that fast. And I'm gonna probably prove that in another video, but that's the theory behind that one. The 170 alkalinity in this did not buffer the pH from rising slowly. The pH just came right on up because you had 170 alkalinity. Okay, now what we're going to do now on the third day is take some pH again, and let's find out how close these buckets are now. This bucket here had 5.2 ppm chlorine yesterday. Today it tested at 5 ppm. Okay, so let's get our pH readings here and let's see where we stand now. All right. 8.2. at 8.21. Let's see if it stabilizes. All right, 8.21. Okay, went up again because of that 170 alkalinity. Okay, now let's see what this bucket is. This bucket, 8.2, stabilizing. Let's see, are we going to get the same pH? Oh, let's see, 8.2, went back down to 8.2. 8.21, guys, 8.21. All right, you know what? There you go, there you have it. What Robert Lowry says is right on the money. Both these buckets now equal the same again, only 3 days later. First day, they both tested 7.79. Third day, chlorine went down quite a bit. Chlorine went down quite a bit. That 1 point in pH, that rise, went down the following day, and it even came back down the third day to match the buckets. Each bucket now matches. So that's awesome. 8.21. That's really good. This is a really good test here. And again, what that just proved is there is no need to add that acid to offset that slight rise in your pH when you pour in that chlorine, because it will go down. It is only temporary. Okay? All right, there you have it.